Now the very first thing that we need to do is we need to place the glass slab on the white sheet of paper. We will trace the outline of the glass slab. After tracing the outline, we are going to keep the glass slab on one side. We are going to give name to this glass slab, that is A, B, C, D. We have the two mediums, air and glass. Air is the first medium, glass is second medium. Air is rarer medium, whereas glass is the denser medium. Now here we find that we are going to draw a straight line, inclined straight line on the side AB of the glass slab. We are going to give a name to this line, that is N dash. This line is called as normal and it is perpendicular to the side AB of the glass slab. We will give a name to this point where the normal is intersecting this side AB. Let the name be O. So this point here is O. Then as we measure a 30-degree angle, we will draw a ray. We will give a name to this ray, that is EO. So this is a 30 degrees angle. Now this angle is called as the angle of incidence. So this angle EON, that is 30 degrees, is the angle of incidence. Over this ray, we have to fix two pins. So on this ray EO, we will fix two pins. It's a soft wooden board, so the pins will easily pierce and they will stand straight. So we will pierce two pins at appropriate distance from one another. Let us give names to these pins, P1 and pin P2. Now this ray here is the incident ray, that is EO. When you have completed this part of your activity, you have to place the glass slab back onto its place. So up till now the glass slab was not there. Now you have to place the glass slab at the same position where you have drawn the outline. After doing so, you have to fix two more pins. How will you fix these two pins? We have to see the images of pins P1 and P2 from the side DC of the glass slab. The glass is a transparent material, so you will be able to see the images of pins P1 and P2 from the side DC of the glass slab. So after seeing the images of pins P1 and P2, you will fix two more pins, one after the other, such that you will find that pins P1, P2, let this be P3 and P4, lie in one straight line. I will repeat. On the ray EO, two pins are to be placed, P1 and P2, at appropriate distance. You have to place the glass slab back into its place where you have drawn the outline. And then you have to see the images of P1 and P2 from the side DC of the glass slab and place two more pins, one after the other. And you will find that all the four pins P1, P2, P3 and P4 will lie in one straight line. So this is pin P3, this is P4. Next, you will remove the pins, remove the glass slab also. You can remove the pins from here also. So all pins are to be removed, glass slab to be placed on one side. And now what you will do is you will join P3 and P4 so that it rests on the DC side of the glass slab. The ray should rest on the DC side. So you have to remove the pins, make small dots where the pins were with the pencil, and then you have to join the points P3, P4 and draw another ray, and it will rest at the side DC of the glass slab. After that, you will give a name to this point here where it is touching, the ray is touching the side DC, and this point is suppose F. At point F, you will draw one more normal as we had done earlier on side AB. Here on DC side also we will draw a normal. We will give a name to this normal, suppose Z, Z dash. So this is also a normal. After that, you have to join point O and F. So you will join point O, F. You get one angle here also, N dash O, F. Then you get one more angle here, and you get another angle here. So these are the angles that we have received after drawing this normal Z, Z dash. This ray, that is OF, will be called as the refracted ray. Here we have another ray, that is FM. This ray FM is called as the emergent ray. Next, what we have done is that we have extended our incident ray backwards. Okay, so we have the incident ray. You have to use a scale. Place your scale on the ray EO and just extend it backwards in straight line. So we have extended our incident ray backwards. After that, you have to join the two rays, the emergent ray and the incident ray which we have extended. You have to join this way. Now this is referred to as lateral displacement. Now what is lateral displacement? It's the perpendicular distance between the incident ray and emergent ray. So we can see that this is a perpendicular. If you see this, this is a perpendicular on the emergent ray. So the perpendicular distance between incident ray, this is the incident ray, and the emergent ray is called as lateral displacement. So the next thing is that you get certain angles. We have already said that this angle here, 30 degrees, which we had drawn, is the angle of incidence. Then the next angle here that you're going to get is the angle of refraction. Here, this angle that you're seeing is the angle of refraction. Here, one more angle we are getting. This angle here is again the angle of incidence, but we will give it a name I1. And lastly, you have one more angle here, that is angle of emergence, that is small e. So with this, we complete the activity that we had to perform. So this is what is the activity. Now we need to understand several aspects of this experiment, and one by one we will try to understand what all changes have taken place in this activity. So let's go on to the next slide.